Alright guys, today we're going to review some exponent rules that you guys learned in Algebra 1 and then again in Algebra 2. And we're just going to go through a couple of these and look at some examples of each one. So the very first one is any number or any variable raised to the 0 power. That is always going to give us 1. And the reason for that, if you think about, if I have x to the 7th power over x to the 7th power, you guys remember from your exponent rules, you can subtract those. So that would be x to the 7 minus 7, which is x to the 0. And we know anything divided by itself is just 1. So the next rule we have is negative exponents. Now these ones get confused a lot with another one we're going to learn in a second. So a negative exponent is basically taking our variable and making it the reciprocal. So x to the negative n is the same thing as 1 over x to the positive n. And if there's x to the negative at the bottom, again, it's the reciprocal and just moves it to the top. Now what you have to be careful with is like with these examples we have over here to the right. If I have 3x to the negative 2, the 3 actually doesn't have that negative exponent. So the 3 has to stay at the top of my fraction. The only thing that moves is the x, because that's the only one with the negative exponent. Now if this was in parentheses, it would be different and that 3 actually would move. But because there was no parentheses, it stayed at the top. Alright, so just like that example comes our next one, where even though there's a negative in front of the 3, it doesn't have a negative exponent. So the only thing that moves to the top is just the x squared. Alright, our next rule is if you have the same base and different exponents and they're multiplied together, you can take those exponents and add them. Okay, but it only works if it's the same base. So like this example over here, I can only combine my two x's together, and I can combine my two y's together. And then we talked about this one at the beginning. If I have the same base, remember it has to be the same base, I can subtract those exponents. So like in this case, I have an x to the 7th and x to the 3rd, so I can subtract that, and that becomes x to the 4th. Now with the y's, if you look, the bigger number is actually at the bottom there. So it's going to be easier for me actually if I start with my bottom number, subtract the smaller number, and then just put my final answer where I started, instead of working with negatives and doing a couple extra steps. Alright, so there are a couple other exponent rules to look at. The next one is a power raised to a power. So in that case, that is the example where I actually multiply my exponents. So that's the only time I multiply them. I don't add them in that case. So for this example here, that would be x to the 6th power. Alright, the next one, if I have one term raised to the same power, both variables in that term can get that exponent, and I can just distribute it. Now you guys have to be careful, because what a lot of you guys want to do is if you see something like this, you want to distribute that n, but you actually can't. If you remember, that's not the same thing. That's actually two different terms inside the parentheses. And we know if we multiply that out, we get x squared plus y squared plus 2xy. Okay, so be careful. This only works if it's one term raised to that power. So if we look at this example here, this is just one term, so every part of that term gets that cubed exponent. So 2 cubed is 8, x is raised to the 3rd power, and then y is raised to the 6th power. Alright, the next one, there's actually two different ways I could write this. Now I have that negative exponent, so if I want, I can write that as a positive exponent, and just flip that whole fraction. What I also can do is I can distribute that n to both the top and the bottom, so I can write that two different ways. So this next example I have here, again, the order you do this in doesn't really matter. What I'm going to do is from the start, I'm going to go ahead and flip this. And since I flipped it, I can just make that exponent positive. And now I'm going to distribute that exponent to every single term. So I'm going to get 8y to the 6th over 64, x to the 9th, and then I can reduce those numbers just like I normally do with fractions, and that reduces to 1 over 8. Alright, the next rule is one that gets confused very, very, very frequently, so this one's going to be really important for us. And this is a fraction. So if your exponent is a fraction, this gets confused a lot with the negative exponents, because the negative exponents involve flipping to opposite sides of fractions, whereas a fraction exponent, the top number is the power that you raise it to. The bottom number is the root that you take. Okay, so you can actually write this one two different ways, and it depends on the order of operations you want to do. If I want to take the nth root first, and then raise this to the m power, that's okay. Or if I want to do this the other way around, if I want to raise this to the mth power, and then take the nth root, that's also will work. So the order we do it in doesn't matter. What really matters is that the root that you're taking is the bottom number. So for example, x to the 1/2 power, that's the same thing as the square root of x to the first power, which is just the square root of x. If I have 4 to the 5/2 power, that means I take the square root of 4 and raise that to the 5th power, which is 32. And the last rule we've looked at a couple times before, that is if I have the square root of a fraction, or any root of a fraction, it's the same thing as if I take the square root of the top or the bottom. So for example, if I have the cube root of a negative 1 over 125, first of all, I can take a cube root of a negative number, because I can get a negative times a negative times a negative, and it gives me a negative number. I could not take the square root without working with an imaginary number. But a cube root is different because any odd root that you take, it's okay to get a negative number. So in this case, that's the same thing as the cube root of negative 1 over the cube root of 125, which is going to give us a negative 1/5. Then the last thing I want to look at is just what we have written up here at the top, and that's an example of something we talked about before with the calculator. Now we have to be careful because these two expressions give us two very different things. If I have negative 7 squared, no parentheses, that's going to give me a negative 49, because that is 7 squared, and then my answer is negative. Whereas this other one with a negative 7 in parentheses, that's actually going to give me a positive 49, because that question is telling me to take negative 7 and then square it. So negative 7 times negative 7 is a positive 49. Where this really comes up is if I have something like x squared, and I say that x equals negative 7, what I really mean is the second one, but a lot of times we type in the calculator like the first one, and it gives us the wrong answer. Alright guys, so that's all we have to review over exponents. After this, we're going to start looking at logs.